eventually close. Sodium is gained. Calcium is gained through transient channels. Then the long-lasting fast channels open, and we see our spike with the voltage. So that's the standard. Remember, that's going to be about 100 times a minute if all we're looking at is the autorhythmic cells of the sinoatrial node. But that's not our average heart rate. So is it sympathetic or parasympathetic that comes to play as we slow the heart down to the average 70, 72 beats per minute?
Parasympathetic?
Parasympathetic. So let's look at what happens with that. I don't have a picture, but I have. So to slow it down, we do that by two things, okay? We affect, parasympathetic is green, right? So we affect the funny channels, and we affect the transient calcium channels through the parasympathetic nervous system. Well, I'll leave that up there. I'll put it up there. So our neurotransmitter for, what's the nerve that's bringing the acetylcholine to the heart? Anybody remember what's our parasympathetic nerve to the heart? Vagus. Yeah, the cranial nerve 10. So acetylcholine is going to bind to muscarinic receptors. And these are G protein receptors. All right? So two things can occur. It will activate an inhibitory G protein. By activate, I mean it's going to kick off the GDP and have a GTP added to it. But the effect of the inhibitory G protein is to inactivate adenylate cyclase. That's going to result in a decrease of cyclic AMP, and that's going to result in a decrease in the number of open funny channels. Okay? So they're not going to open until the current becomes much more negative. So that's one thing that it does. Okay? That's this one right here. Go to the, well, it's the calcium one, but it also works on the funny channels. And the other thing it does is it activates a stimulatory G protein, which binds to and opens potassium channel. What's that going to do to the membrane potential? It's going to make it more hyperpolarized. It's going to take longer. In other words, it's like trying to fill up a bathtub, the water being the positive ions of depolarization, by turning on the faucet. That's what's going on here. But then with acetylcholine, we pull the plug. So at the same time we're trying to add more positive ions, we're losing positive ions via the potassium channels. And so it takes longer to reach threshold. Okay? We start at a lower level, and it takes us longer to get to threshold because we're losing ions at the same time we're gaining them. So what that does is it increases the time between action potentials, makes fewer action potentials per minute. We require those to trigger the ventricles to contract, so we have a fewer heartbeats per minute, a slower heart rate. Okay, does that make sense? If you understand the overall? So if we go back to our regular autorhythmic, what's triggering this is the funny current opens. Okay? And we add both positive sodium and calcium to reach threshold at 100 beats a minute. Acetylcholine comes along, and we have fewer funny channels. They don't open as early, So it takes longer to get to this point. Plus, we're losing positive ions through our potassium channels. So it takes even longer to get additional positive ions into the cell. Okay? That's how we slow the heart rate down to our standard 70 beats a minute if you're looking at the average. Now, the heart rate can be slowed even more by continued activation of the vagus nerve, all right, through a vagal stimulation. Or, as we'll see when we do talk about cardiac output, by the force of the heart's contraction. So someone with a strong heart doesn't need to contract as often. For instance, average heart rate, 70 beats a minute, average stroke volume, that's the one volume for each ventricle when it contracts, about 70 mils. 70 times 70 brings you to about 5 liters, 4,900 mils. Okay? So average cardiac output per minute is about 5 liters of blood. You only have about 5 liters of blood, so obviously it's being pumped out over and over and over. Now, let's say that someone exercises, and with each heartbeat now, their heart is stronger because it's been exercised like any muscle. And instead of 70 mils, it can contract and pump out 100 mils. So what does a heartbeat have to be to pump out a 5,000 mils? It only has to be 50 beats a minute. All right? So we don't want to pump out too much. Our blood pressure would rise. So the body maintains a balance between its need for oxygen and blood pressure regulation. So the stronger the heart, the greater the volume per contraction, the fewer the number of contractions that need to occur. So that's why we see that balance. So we talked about a weak and thready heartbeat. So if there's not much blood volume, so whenever the heart contracts, we've lost blood through hemorrhaging. So now when the heart contracts, it's only pumping out 30 mils instead of 70. All right, with a heart rate of 100, you still only have a cardiac output of 3,000. So the heart rate has to get increased to try to get the same amount of blood circulating every minute. So that's we'll look at that relationship when we look at blood pressure. Okay, so slowing the heart rate. Now, we do the reverse when we increase the heart rate. So I'll leave that diagram up and erase the green structures here. So now sympathetic nervous system is going to increase heart rate. So we're looking at norepinephrine or epinephrine. Epinephrine comes primarily from the medulla. Norepinephrine would be from our sympathetic nerves via the thoracic spinal cord. It also is going to bind to a G protein. So we have G protein activation. This is going to activate adenylate cyclase. Therefore, that's going to increase the number of cyclic AMP, which will bind to our funny channels, as you can see here in the diagram. And they will open earlier. So this increases the number of funny channels that are open. And it also, they open earlier, meaning they open at a less negative, like a minus 45, so they don't have to wait until they get to minus 55. So they're going to open, say it here, instead of down here. We also increase the rate at which we add positive ions because they will open the transient calcium channels. So these transient channels here, more of those will open. So not only do we not have to wait for the cell to hyperpolarize as much, but we have more positive calcium channels open and we're adding calcium at a faster rate. Okay? So this will happen, and more transient calcium channels open. kind of the reverse, except for the potassium component, but the calcium and funny channels will open earlier and more of them.